I'm Alex Brown, and I'd like to introduce you to the Composite Deck Slab Analysis tool. This tool helps structural engineers evaluate composite deck slabs for superimposed distributed and concentrated loads, maximum allowable unshored spans, diaphragm capacity, performance for multi-span conditions, vibration performance, and strength-based slab checks, all with efficient inputs and full calculation transparency. Let's jump in. First thing you'll notice, this tool is structured very similarly to the bare deck analysis tool, where we have the main inputs on the left, and then multiple calculations and analyses that can be run are all listed here on the right side. So you can see there's quite a few of them. We're going to go through every one in a little bit, but I do want to point out this concentrated load. So this is new. We did not previously have a tool that could handle concentrated loads on a deck slab, but based on the general inputs, so the type of deck you're looking at, the concrete you've got on it, and then some of these parameters here, what kind of shoring it may or may not have, the supports, what kind of loading is already present. Based on all of that, for an individual condition, so you can punch in your span here, and then that will tell you the maximum allowable concentrated load. We call it the variable position concentrated load, so that's that acronym here. And it tells you what that is inward and outward per rib of deck. So all of that listed here. The goal for all of this is to have a one-stop shop for all calculations. You can print it. So in this example, I can print my analysis. That'll show all of the calculations that went into figuring these numbers. Then that's something I can pass on in a calc package on the whole job. Up top, you can input a job name and a description name. So as the tooltip shows there, this will be in the output file title and the footer of the PDF that you download. So just a way to keep things organized, especially if you're working on different parts of a project or different projects entirely. So this section 1 here, deck selection. First off, you can determine if you're in the Verco portion of the country or the Vulcraft part of the country. So that's the first drop down here, is just selecting one or the other. And you can see when I make that change, it'll redo some of the inputs here. And that's generally how this tool works, kind of working from top to bottom. As you update your selections, it'll update the different options that are available for each one. So we'll start with a couple of Verco inputs here. So Verco, yes, composite. You'll notice it only has composite deck. If you need something else like a bare deck analysis, that's what that tool will be for. For the family, we will do the 3-inch W deck. And then if I jump ahead a little bit here, you'll notice that for acoustic, it only shows no as an option because we do not have an acoustic non-cellular option. So if I need an acoustic 3-inch W deck, I need to make it cellular, and then that opens up this acoustic option. And you can see as I'm picking all of these, my profile here is updating as well. So interlocking side lap with punch lock deck, I can change that. So all of that goes right here. And then sometimes, depending on the parameters, you may have multiple profiles that are available as an option. So that will all populate here. And then gauges can be selected, and the grade of steel, if there are multiple options, again, you can select there. So I'll flip this over and show a quick Vulcraft example. So yes, composite. So 3-inch deck, it kind of retained that equivalent deck type. So 3-inch composite trapezoidal shape. The cellular and acoustic are still valid options, so those did not reset at all. But you'll notice scrolling through here that my side lap changed to button punch. I can change that here. My profile is updating on the fly. 3 VLPA, 2020, grade 50. It's a lot of the same functionality. If I change this to an 1.5 VL deck, I do have 2 different options here for the profile itself, because in some parts of the country, we offer a 24-inch wide cellular deck versus the 36-inch wide. So if I've got that kind of visibility, if I'm speaking with my local Vulcraft or Verco office technical expert, that's something that I can plan for, and I can get a very precise analysis within this tool for that specific profile. And if I go over to the superimposed loads here, with this particular deck selected, you'll see that my tables are completely blank. I have no values to work with at all. And the reason for that is because of that 8-foot starting spacing there. It's an unshored span. This particular deck, very thin with concrete topping, it can't actually get up to 8 feet. So one solution, maybe I am shoring this deck. Maybe I do need it to get up beyond an 8-foot span. So if I'm shoring at mid-span, that starts to give me some capacities. So for a 20/20 arrangement, I can get all the way up to 10'6" with a 1043 PSF load capacity with LRFD. But maybe shoring isn't possible. So if I flip that back to unshored, and I just need to know what's the maximum capacity of this particular deck, I can drop that down to, let's say, 4 feet. And that resets what these tables are publishing. And then even the span increment, I can mess with that as well. So that's at 1/2 foot right now. So going up by 6 inches, I can adjust that down to the 1 inch increment at the lowest. And then with the values, you'll see that, again, it kind of stops short here. It really doesn't get beyond 7 feet. And we'll get into that later. It has to do with the maximum unshored spans that this particular deck and deck slab can take. So once that is exceeded, this particular part of the tool doesn't print any values because it's just showing based on that unshored requirement that we looked at here. So if I change this, let's make it a little more common of a deck. So we'll drop the cellular requirement, and you'll notice that also wiped out the acoustic requirement. And you'll notice that the side lap fastener is only showing screwed, and that's because the side lap type is still here as a nestable screw option. So that's our VL deck in Vulcraft nomenclature. The interlocking profile is VLI, and that side lap fastener defaulted to punch lock, but button punching and welded is also possible with this particular deck profile. So something else I'd like to point out is this graphic down here. So you may have noticed that this updates as the different options are selected. So this is the VLI, so it's actually showing that interlocking side lap there in the middle. If I were to change that back to nestable with a screwed condition, that changes there. And in fact, if I change the profile entirely to our reversed profile, VLR, that actually flips it upside down and shows kind of how that concrete would then fill in while still maintaining the same slab depth. So this just serves as a quick visual confirmation of everything that you're inputting for the deck, for the slab height. You can see that shrinks up. All of my values are updated on the fly. So a very powerful tool, very quick responses. Something else you may notice is that the 24 gauge option is not available. So that is the error sign here in the calculation. And that is because that is not available in grade 50 steel. So if I change the gauge from 22 to 20, that actually changes the grade from 50 to 80 class 1, because that's the coil that we actually run this particular profile with. It's kind of limited at a little over 4 feet here, and that's going to have to do with the maximum unshored span, just because that 24 gauge gets very light. So let's switch to one of our dovetail profiles. So the deck family, we'll kick that up to a 3.5 inch dovetail. We'll give that a second to update. You can see the new graphic, new values, new options here. So the profile defaults to our 3.5 inch dovetail stiffened profile, though there's a flat option as well. So you can see in that graphic, very slight difference there where we do not have the stiffening ribs. And then for the slab depth, I can change that to show a very shallow concrete topping, so 5.5 inch slab depth, all the way up to the maximum 9.5 inch, and that graphic will update accordingly. So the superimposed load tab, we've talked about it a little bit, but really the purpose is to evaluate how much loading the composite floor system can support under my selected conditions. So this gives engineers a fast way to review the performance of the slab for typical loading scenarios on a project. And then up top here, you can define the relevant loading criteria and then review the results in a clear tabular format. So this is going to support quick summary outputs with each result backed by a more detailed engineering analysis available by hitting the print button. And that's really useful when you need an efficient answer, but also need that ability to show your work, show the calculations, and kind of trace it back with the governing calculations. So if I change that span increment, take it up to 1 foot, let's say. So I can see with this particular deck, I'm getting capacities up all the way to 12 feet. If I kick that up a little bit more to an 8 foot starting, now you can see it starts to kind of taper off here. And that 15 foot span, you can see there's an asterisk shown right there next to the value. If I scroll down here, sheet lengths are limited to 42 feet. That is the absolute maximum that our deck manufacturing plants can support, just with the physical space available across the country. So you may see that note start to come into play at some of these larger spans, And the 3.5-inch deck, just because of that depth, because of that maximum span, you start to run into it a little bit more. So there's this number of panel spans option here, 1, 2, or 3. So that's pretty open-ended. I can dial that in further. So if I know that I'm going to have a 2-span condition, no more, no less, well, now I can get up to, say, a 16-foot span, because that's only going to be a 32-foot long sheet of deck, whereas a 3-span would be 48 feet at this spacing of supports, that deck span. So once I have this dialed in, I've got my bearing lengths figured, I've got my construction live load during placement, so light, medium, and heavy, and that comes from ANSI and SDI SD 2022. My deflection limits are all plugged in, ponding allowance. So based on all of that, I can go ahead and print my summary. So we'll show that real quick here. And then even within the file name, you can see that it's got that job 1, area 1. So those names there are included in the file name itself. All of my tables are printed here. So this is very similar to what you may find in our printed literature with maximum spans, maximum allowable loading. I've got that same graphic that we showed earlier. So that's printing the summary. If I want to get to a specific analysis, so say that 16 feet that we were looking at, and you can see that maximum span governed by shoring conditions is just a touch over 16 feet. I can print that analysis. Open that up. And you can see all my calculations are shown here, really documenting the work that the tool is doing and how it's coming up with those different values. So moving on to the unshored span analysis. This part of the tool is going to help evaluate the deck during construction before the slab has cured and become part of that composite system. So this is going to be useful for checking allowable construction spans and understanding what the deck can support during placement and some of those early stages of erecting and loading. So again, that construction live load during placement can be selected here. That's going to be a really important factor in these calculations. And once again, we've got that reference there for where light duty, medium duty, and heavy duty references are coming from so that you can select the most appropriate one for how your job will be erected. And we'll go ahead and increase that to 50 PSF for medium duty. And with that, you can see those values updating there. And then looking at this ponding allowance here, and also my unit weight of concrete as 145, maybe this project is actually going to switch to a lightweight concrete design. So we'll go ahead and change the unit weight as well as that ponding allowance to something typical. And then with those changes, again, you can see those values updating on the fly, taking all of this into account. I do want to point out these WDD and WDS values here. So that's listed alongside each gauge. So that's the dead weight of just the steel deck, the DD, and then the dead weight of the slab, including concrete, not including ponding. Those values are all listed here as well. And then every limit state is checked and the calculated value is displayed here with the worst case value being the governing limit state. So I can print that analysis here for an individual span condition. And then at the bottom here is the cantilever check. So for an 8-foot span, that results in a maximum 5 foot 6 inches cantilever. If I kick that up to the 16-foot span that we were looking at, that increases my maximum cantilever a little bit there. Moving on to the diaphragm section. So this is going to allow you to evaluate diaphragm-related behavior as part of the full system review. And that's really useful when the final deck slab is contributing to that lateral support of the structure, perhaps in a multi-story building, some sort of a mid-rise or high-rise structure. So you as a designer will need to define your chords and collectors and then choose the reinforcement of the composite design. And then also, you may notice that this part of the tool works a little differently than the rest. So for like unshored span or superimposed loading, we defined sort of what the condition was, and then the tool gave us what the maximum allowable demand can be, the capacity is. Whereas here, I'm entering my required shear strength, and then it's going to inform me what I need to do in order to accomplish that. So perpendicular connections in one and every other rib. I can define that fastener here. So it's either a shear stud, or if I have something else, I can really dial in what that fastener is. And in fact, wood is also supported. So I'll show that briefly also. There's a couple of different commonly used mass timber options shown here. If you have suggestions for additional support members, feel free to email us at designtools@nucor.com. But basically, if you're using typical things, we can figure out what's going on. But if you have something custom or specific, you can get that punched in here, and then we will take that into account as well. So I'll flip that back to just a standard shear stud. And then for the reinforcement condition here, so that's temperature and shrinkage at the moment, but I can change that to strength reinforcement. And again, kind of like with what we were looking at for the fasteners, I can start dialing that in for either specific mild reinforcement, so some different sizes there, fiber reinforcement. So we do support Beckert-Dramix fiber reinforcing. So that's the required quantities in order to achieve the different values, or you can mix and match. So that would be here, and then that would be taken into account too. I'm going to change that back to temperature and shrinkage, and we'll move on to the next tab here, which is strength properties. So you see some of the default values have gotten a little confused just as we've changed different deck types throughout this example here. So I'll go ahead and reset some of these just to be valid numbers. So that needs to be 3/4 of an inch, and that one also, and then these are okay, just to see some sort of an output here. And then I'll also point out that the mild reinforcement that we were just looking at in the diaphragm tab does carry over into this tab also. So these do stay synced up between different parts of the tool. So this part of the tool is a very important addition to the suite of design tools we offer on our website. So here you can enter transverse and longitudinal reinforcement details, and that's going to be used to calculate moment strength, shear strength, and punching shear strength. And really that gives you a more complete understanding of that deck slab behavior and helps connect the analysis to actual reinforcement conditions in the field or in the design documents. And it's going to make the tool more useful for situations where reinforcement layout significantly affects the allowable load. So once again, the goal here is to make this tool transparent and make our product as easy as possible to work with and design with. So moving on to the concentrated loads section here. So this part of the tool can evaluate point loads either downward applied at the top of the slab or upward applied at the bottom of the deck. So that's going to include things like suspended MEP loads, anchor related loading, braces, etc. So you can enter your loading conditions and then see how that deck slab system is going to respond, what that allowable loading is going to be printed at the bottom here, because it's checking the reserve capacity of the slab and then giving that back to you in this format of a variable position concentrated load. And then that can also be useful for checking existing slabs also, if you know how that slab was constructed, what type of deck and concrete was used for it, and then what kind of loading you're expecting now, you can get whatever that reserve capacity is. So moving on to the final two analysis methods here, multispan and vibration. For multispan, this is going to be really useful because it looks at the entire system beyond just a single isolated check, and that matters for a real floor system. That's going to depend on span continuity and serviceability, and you can really kind of analyze it as an entire system. So a lot of the same inputs here. What's my loading criteria? What's my deflection criteria? I can do time-dependent deflection. All of that is supported here. And you can see I actually don't have any outputs right now. So I got a couple of different errors just because of some of those default values. So we'll adjust the rebar cover thickness. And then my span is also a little bit too high. So clearing some of that out, I'm able to get some serviceability checks here. So in this case, based on the deflection criteria I've inputted, those do pass. I have a very stiff deck slab, it looks like, so that's not moving very much at all. And vibration, very similar. What kind of a span am I looking at? What's the end condition that I'm looking at? Fixed, pin-pinned, or a mix. And then the superimposed dead load and live load, that's going to resist some of that expected vibration. And I'll point out these are not the worst case design loading that you were doing, because in that case it would be unconservative for a higher value. Remember, this is resisting vibration. You want lower numbers to be more conservative. So there's some suggestions there. AISC and the Steel Joist Institute have some design guides with guidance on what kind of numbers to figure for that. And then based on those inputs, this generates the harmonic natural frequency of the slab, and then a minimum harmonic natural frequency for that, and it compares them and tells you if it's acceptable or not. The big takeaway from all of this is that composite floor design is rarely about a single variable or a single check. A deck profile that might be more expensive potentially, like our 3.5-inch dovetail compared to like a 2 or 3-inch VL deck, is going to have trade-offs where the overall system is benefiting from reduced slab thickness or less concrete or improved fire rating, easier installation, reduced labor, etc., etc. So this tool really gives you that broader look at what the entire system is doing so that you can make a really informed decision and have that full transparency over what kind of performance you're going to get out in the field. And that's the Bare Deck Analysis tool. It's an incredible tool that lets you check nearly every aspect of a composite deck slab, and it greatly expands on the published values in our literature by supporting all deck types, as well as custom conditions, attachments, and table spans. So with that, happy specifying.